So now what is radiation pattern? What is radiation pattern? Okay, what is radiation pattern? Okay, then the radiation pattern is function of what in general? In general, the radiation pattern is function of theta comma pi. This is something strange because you are always using R, but here R will not come. Your radiation pattern is in general function of theta comma pi. Then how the radiation pattern is measured? Then from this one thing is very clear. When you are changing theta and pi, then R is equal to constant. Then what is R? R is equal to constant. Okay. Now, see, suppose if I am having a tower like this, I'm having the tower like this. I'm standing on the imaginary circle. I'm standing on the imaginary circle. Okay. And again, this is, say, for example, this is of 0 degree. Okay. When I stand here, okay, when I am standing here, I am measuring my electric field. Okay. I am having one handset. Okay. I don't know the nature of this tower antenna, but what I am doing, I am drawing one imaginary circle around the tower. Okay, when I am drawing imaginary circle around the tower, what is R? R is constant. Okay, you can draw anywhere. Okay, of smaller radius or bigger radius, that's okay. So some R you have to choose. R is constant. Then I measure how much electric field I am receiving. Okay, then in later classes I will tell you how to measure the electric field, how to measure the magnetic field with the help of your cell phone. Okay, but for the time being, just listen here. See, I am trying to measure what is the electric field. Okay, I'm not worried about how much magnetic field is there, how much power is there, but one thing is very clear. If it is EM waves, if electric field is there, definitely magnetic field will be there, definitely some power will be there, that's okay, but I am measuring only electric field. Okay, electric field is always what? Volt per meter. Electric field means always volt per meter. Somehow I am measuring the electric field. Say for example, I am getting 10 volt per meter. I am getting how much, sir? 10 volt per meter. Now, what happens if I move along this line? I get here, say for example, at this point, say I get around 9 volt per meter. When I stand here, I get, because I don't know the nature of this tower, but I am trying to analyze the nature of the tower. When I move along the line, first 10 and 9 and then 7, 6 volt per meter, like that it comes. When I go exactly at 90 degree, then I am getting 0 volt per meter. Then as I move along this line, I am not at all getting signal. 0 volt per meter I am getting. Here also 0 volt per meter. Here also 0 volt per meter. And I come here also 0 volt per meter. Then gradually it increases. Here it comes 1 volt per meter and then 2 volt per meter and then 6 volt per meter. Then finally, once if I go here, definitely I will get 10 volt per meter. Then how to draw the radiation pattern? How to draw the radiation pattern? Okay, so I draw this line like this. Okay, so what is happening? See, when I get now, when I draw the radiation pattern diagram, I will normalize my values. Okay, whatever the values that I am having, I will normalize. Once if I normalize, what is the normalization, sir? E divided by E max. Whenever if you want to normalize something, what is the maximum value present there? If I want to normalize all these values, then what is the maximum value? The maximum value here is 10 volt. Just for diagram purpose, I am normalizing, or directly also I can draw the diagram, no issues. But once if you normalize, then that will be better. Okay, so then here I am getting magnitude as 1. Okay, exactly at 0 degree, I am getting magnitude as 1. As I move along the line, my magnitude is getting decreased. Okay, but another thing is also visible. When I move along the line, what is happening? My angle is changing or not? Anybody? See, when I move along the line, my angle is changing, but you cannot go on the circle because your magnitude is decreasing. Your magnitude is decreasing. That's why the pattern goes like this. The pattern goes like this. Okay, so if this is 1, then somewhere it comes 0.5, 0.4, 0.3, and then finally 0. Okay, at any point of time, this is maximum value 1. Then accordingly you have to put your point values here. Okay. So similarly, once if I draw the diagram here, this goes like this. Okay, this goes like this. Okay, this is the radiation pattern measurement. And again, here, this is independent of distance because you are at fixed distance. And again, please remember the radiation pattern diagram, you should not use any R because your R is constant. Okay, you should not use any distance. Radiation pattern is function of angle. Radiation pattern is function of what, sir? Angle. Radiation pattern is function of angle. Okay. Now, one more thing I want to know. Now I am on the base plane. Okay. So when I stand exactly at 0 degree, I am getting maximum power. When I stand at 90 degree, I am getting zero power. Once if I come this side, no power. But when I am in between 0 to 90 degree, I am getting some power. That means what? This particular antenna is focusing only on the positive x-axis. Okay, its main aim is what? To focus the power on positive x-axis. So, well, again, in case of that, it will also focus some direction, nearby direction also, because exactly you cannot focus on a point. Okay, because that is possible only in case of satellite. But here, around some direction will be there around, apart from plus x. Okay, here also the power is there for some degree, okay, this is the radiation pattern. Radiation pattern is function of angle. Okay, because this is angle. When I stand here, my angle is 0. When I go here, my angle may be 10 degree. When I stand here, my angle may be 45 degree. When I come here, what is my angle? My angle is 90 degree. Okay, so radiation pattern is function of angle. Then that too, I am drawing the radiation pattern for the base plane. For the base plane, what is constant? Theta is constant or pi is constant? Anybody?
Theta, sir.
For base plane, yeah, theta is constant. Then that means what? This is function of, this diagram is function of pi. This diagram is function of pi. Then where I have drawn my radiation pattern? Exactly on the base plane, horizontal plane. So I have drawn this on the horizontal plane. What is another name for horizontal plane? The another name for horizontal plane is azimuthal plane. Azimuthal plane. And again, this azimuthal plane, we can tell the another name for azimuthal plane is theta is equal to pi by 2 plane. Okay, this can also be called as, please refer coordinate systems. Okay, what is the base plane? Base plane, you can call it as a theta is equal to pi by 2 plane. Base plane, another name for base plane or horizontal plane or azimuthal plane is theta is equal to pi by 2 plane. Okay, theta is equal to pi by 2. Okay, because first your theta is constant, then you are varying your pi. Then next what I will do, I will fix pi, then I will vary the theta. I will fix pi, then I will vary theta. Okay, that diagram is called again another radiation pattern in the elevation plane or vertical plane. Elevation plane or vertical plane. There pi can be anything. There pi can be anything. Overall, Purida sir, what is radiation pattern? Radiation pattern is always function of angle. It is independent of distance because you have to fix your distance. Whenever you are going to draw the radiation pattern, you have to fix your distance. Okay, then you have to vary your angle. Okay, then vary your angle. If your power is more, you put more magnitude. If your power is less, you put less magnitude. Okay, that is the idea to diagram, idea to draw the radiation pattern, idea to draw the radiation pattern. Okay, so I'll write the definition. So what is radiation pattern? This is the locus of received E field, locus of received E field at a fixed distance, at a fixed distance. At a fixed distance means what, sir? R is constant. Fixed distance as a function of other, as a function of other space coordinates, as a function of other space coordinates. Okay, because once if you are fixing the distance, what is other space coordinates? Theta comma and pi. Theta comma pi. So the radiation pattern can also be called as field pattern or power pattern. Radiation pattern. Okay, radiation pattern can also be called as field pattern or power pattern. Okay, once if you draw the radiation pattern for E field, then that is called as field pattern. Field pattern, or sometime you can draw it for power also. How much power you are receiving? That time that we will call it as a power pattern. That time we will call it as a power pattern. Okay, so this is the radiation pattern. In general, that will be whenever you see the radiation pattern, that will be always function of what, sir? Theta comma pi there, because r is constant. Okay, then when you have some distance between the transmitter and the receiver, say for example this is transmitter and this is receiver. Okay, then again you are transmitting something, you have to receive the same information. Then what is the distance between the transmitter and receiver? Okay, when it is very small, what will happen? Okay, I am putting my both transmitter and receiver very close to each other. Say the distance is of less than 1 centimeter, very close to the transmitter. Then what will happen? Okay, that means what? This is say r, distance between the transmitter and receiver. Okay, now once if r is the distance between the transmitter and receiver, distance between transmitter and receiver, then there are two field. One is called near field and another one is called far field. One is called near field and another one is called far field. When your r is greater than 2d square by lambda, d means dimensions of the antenna, then that particular area is called Fraunhofer far field region. Okay, just I write down, then later I will give you the diagram. Okay, far field, Fraunhofer far field zone. Okay, Fraunhofer far field zone. Once if r is again Fraunhofer far field zone. Okay, once if it is far field, the another name for far field is radiated field. Radiated field or active field. This is very important because radiation is important for us. That particular field is called radiated field or active field. Or if it is less than 2d square by lambda, then that is called Fraunhofer near field. Fraunhofer near field. Whenever you are in near field, you will not get the signal properly because there you will have only reactive power. There you will have only reactive field that is not used for radiation purpose. Okay, not used for radiation purpose. Okay, so see what is meaning of this one. Say if I am having antenna, please mute your mic, others. If I am having transmitting antenna like this, what is happening very close to antenna, very close to antenna, some power is there. Okay, some power. That power will not go to longer distance, that power, but after certain distance, say whenever you are inside, that is called near field. If you are inside, say this is called near field. Then when you are outside, that is called far field. When you are outside, that is called far field. Okay, and again the limit is set by whom? The limit is set by this r. R is equal to 2d square by lambda. Anyway, once if you know the operating frequency, you can calculate lambda. Then d is the dimensions of the antenna. Then you know distance. And please make sure that the unit is correct because this is ultimately meter. Finally, whether that is working or not, finally meter. So once whatever the power that is available here, it will be here only. That will not go to longer distance. Okay, that particular field is called reactive field or near field. Okay, because that is not useful, because whenever you have a power that has to go to a longer distance, Okay, so some portion of the power that is transmitted by the antenna is available only in the near field. Say for example, around 5% of the power will be available at the near field. The remaining 95% of the power only will go to the far field, okay, other areas. Okay, but the near field, with the help of near field you cannot do any communication. Okay, with far field only you can do the communication. Okay, signal goes on the far field. Okay, so far field, with the far field only you can do communication. Okay, with the near field, because near field, with the near field you cannot do any communication. With the near field you will not have any communication, not possible. Communication not possible. Communication not possible. Okay, what is the another name for near field? Reactive field. Reactive, another name for near field is reactive field. Another name for far field is active field. Active field, it can go to longer distance. Okay, so in the difference therein, and I will give you another formula for to separate near field and far field. For the moment you just take down, later I will explain the another limit that is decided. Okay, for in some cases we have to use some that formula. Okay, that is lambda divided by 2 pi. What is lambda divided by 2 pi? What is 1 by 2 pi? Anybody? I think 0.16 lambda. So the another limit to identify the near field and far field is this formula. Okay, whenever you are given with dimensions of the antenna and everything, you can use this formula. When you do not have that information, only if you are given with lambda, then you have to use this formula. Okay, then I will tell you how this formula is coming later. Okay, 1 by 2 pi is correct or not? 0.16. Anybody?
Yes, sir, correct.
Okay, 0.16 correct. Okay, so with this I will